Today we're going to go over the notes for enumerations and switches. So when we think about code in life, a lot of times we need to select just a single choice from a set of options. I'm going to give you some examples. Example number 1, let's say we are ordering a picnic and there are just 3 types of sandwiches to choose from: ham, turkey, and vegetarian. Someone would need to choose only one of those 3 controlled choices. Example number 2. When you go to the store, you need to choose the correct t-shirt size. So we're looking at extra small, small, medium, large, extra large. You get one choice out of the choices that are given to you. You can't just make up a size. They're not custom making that for you when you are at the store. You need to select from choices that already exist. And final example is selecting movies at the cinema. So over time, the choices change, but on the day that you go to the cinema, there are only a finite number of options available to you. So in comes enumerations. Enumerations are a set of controlled choices. An enumeration represents a group of related choices. So in our example on the previous slide, a small, medium, and large size t-shirt are all related, but a medium-sized t-shirt and a ham sandwich are not related, of course. There are 3 best practices when we create enumerations. First is our keyword. Our keyword is abbreviated to enum. So enumeration and enum is our keyword for that. The name of an enumeration is capitalized, just like they were when we created structures. The name of an enumeration should be singular. So lunch choice, for example, not lunch choices. Each choice is called a case. The name of a case is lowercased. So if you have 3 or 5 controlled choices, then you would have 3 or 5 cases. You can define your own enumeration types, just like you can define your own structures. A few more notes here. With enumerations, choices are limited to one of its cases. You may only select one option at a time. Autocomplete will show you those possible options by using dot notation. All right, let's see how this actually looks with syntax. Here we have an enumeration example called lunch choice. And in our lunch choice enum, we have 3 cases or 3 options. We have a case pasta, a case burger, a case soup. So really our 3 choices for lunch are pasta, burger, and soup. We encase those cases, or the body of our enumeration, in curly braces. This is set up a lot like a structure. Here's an example of an enumeration instance. So here's a constant. Let choice be lunch choice. So you use the name of the enumeration, dot notation, and autocomplete will generate our 3 options, pasta, burger, or soup. Here we have used dot burger. This example, let lunch choice be lunch choice dot pizza, will not compile because pizza is not one of our 3 options. Let's look at another way to do the same thing. Here's the same enumeration example, but it's written a little differently. we still have the enum keyword. Lunch choice is the name of our enumeration, and then inside the body of our enumeration are still our three cases. But this time we have the case keyword with all three options separated by commas. Both are correct. You can choose either. Here's a little bit of a different way to create instances of enumerations. Here we have one that's a variable, so we can have constants or variables. Here our lunch choice is burger. This is our initializer, it's our first one. And then we have an instance where we have updated that variable to pasta. So here's the question. When do we use enumerations? Well, when you have a restricted group of related values. So, for example, in a game application, each player has these properties. Every player has a name, a skill level, a team, and a position. Name and skill level are really good parameters just to pass into our character or to assign them in a structure. But our team is a great enumeration choice because generally there's just two teams to choose from. So let's say you want to be on the red team or the blue team. There are no other choices, so enumeration makes sense here. Same with position. Imagine this is a soccer game and there are about 5 or 7 positions on the soccer field. You can force a choice for one of those positions. This makes sure that we're not creating positions that don't exist. Again, an enumeration makes a good choice here. Here are some comparisons. We have the same lunch choice enumeration. In this case, we have pasta, burger, and soup. And I have two instances. I have my lunch instance and your lunch instance. In this case, it looks like we've both chosen the burger. Here I have a conditional statement worked in. If my lunch choice dot burger, is equal to your lunch choice dot burger, then we're going to print we're having the same lunch. And if anything else, if they do not match, then we can print, can I try your lunch? Go ahead into a enumeration. You can create a new playground here, enumeration, you can call it, and give these a few practices. Enumeration values can be used as parameters or return values for functions, so this is pretty cool. And again, autocomplete is going to tell you what your options are, so you don't need to have the choices in your enumeration memorized. Again, we have the lunch choice enumeration. And then immediately after, not inside, but outside of our enumeration, we have the function cook lunch. Here we have a parameter for choice, and our choice options or data type is lunch choice. So this is going to force us to choose one of these options, pasta, burger, or soup. And we can return a string here. So if the choice is pasta, then we're going to return the pasta emoji. If the choice is burger, we'll return the burger emoji. Or if it's something else, we will return the soup emoji. Okay. So if I call this function cook lunch on the parameter value of burger, I'm going to get a return of a burger emoji. I'll go over these in a few minutes. If statements, like we have here, are actually not a great fit for enumerations, but switch statements are. Switch statements connect a case with a code. That way, if the value checked matches the code statement or the case statement, then that code will run. What is problematic with a conditional statement or an if statement is this like default here. Well, we don't want any other choice. We want the only three choices to be pasta, burger, and soup. If I say, if my choice is equal to, let's say, a smoothie, for example, well, I don't want to return the soup emoji because that would be wrong. So switch statements are better than if statements for enumerations. This switch statement pairs a result with every single case. Let me show you how that looks. So again, I have the same enumeration with three cases, pasta, burger, and soup. My choice today is a burger. And here's my switch statement. So I set this up a lot like I set up my enumeration. So I have a switch called choice. Okay. And if my case is pasta, I put a colon here and my return here. Okay, case for burger, my burger emoji, and if my case is soup, then it will return soup. This way, it pairs each of my enumerations tidily with a emoji. We do have a default case in case you do not want to create a condition or a switch statement for every single case. So let's say we have this new enumeration example, quality. I have 5 cases here, bad, poor, acceptable, good, and great. I've initialized the quality to be good. Then I can create the switch statement for quality that goes through each of my case options. So if my case is bad, I have a print statement that says that really won't do. If my case is poor, I have a print statement that says that's not good enough. And if I have anything else, or my default will print, okay, I'll take it. So that would be if it's acceptable, good, or great, it will print this default switch statement. I can also lump multiple cases together. Instead of a default, I can group certain cases together to turn out certain results in this example here. Switch statements can be used for other purposes if you're using the default case. So let's look at the animal that we have assigned the string cat. So let's say we have a function that gives us the sound of an animal. So animal is our parameter. We return a string that is the sound of the animal. So we have this switch statement embedded in the body of a function so that in the case of cat, it will return meow. In the case of dog, it will return wolf. And then we have a default. If it's anything other than those two, it will return, I don't know that animal. And you can call the function just as we've done here. Finally, we have the self keyword in methods and computed properties. Self refers to the instance that's being asked for the property value. So it's kind of like if we are asking ourself, right? If we want to look at ourself and compute within ourselves. So again, this is a keyword that's used in methods and computed properties. So let's take a look at this lunch choice enumeration. We have a variable emoji, that's a string type, and a switch on our self. Okay. So a switch on our self will give us a case for pasta, burger, and soup. We set up our initializer in the same way, and we can access our emojis by tapping into lunch.emoji. We're going to move over to an enumeration practice playground just to type these out and see how they all look. All of these are going to be a repeat of what we've just done, but inside of a playground. All right, let's get into enumerations. I'm going to use my keyword here, enum, and we love when that turns pink because it shows us that we're doing it right. All right, I'm going to put in lunch choice. I would love for you to follow along with me. I use my curly braces to host all of my cases, and I'm going to list my cases for lunch choice. My first case is pasta. My second case is burger, and my final case is soup. Okay. Then I can let my choice, so here's my first instance of making a choice from this enumeration. So I do lunch choice, dot, and then when I use that dot, it gives me my cases with a K. Burger, pasta, and soup. So I'll choose burger here. Okay. And that runs just fine. However, if I had put in pizza, this code will not compile because it says, hey, there's no member called pizza. There's no case called pizza in our lunch choice enumeration. So that's one example of enumerations. Let's do another enumeration and just write it out in a different style. Let shirt size. Okay, so we have a shirt size and we have a case for small, medium, and large. Then I can let my size choice. I can choose from shirt size, note the E for enumeration, use dot notation, and it lets me choose from large, medium, or small. And there we go. These are two different ways to write enumerations. Cases on each individual line, or all the cases listed together and separated by commas. I can use a variable here to actually update my size choice. And then I just use dot notation and I can add in my new and updated size choice. Okay. I can compare enumerations. Okay. So let's let Yunsi's lunch, and then I'm going to choose from my lunch choices. Okay, and I'm going to have her choose pasta. And then I'm going to have Cha, his lunch be, again, we choose from our limited choices. His lunch will be soup. Okay, so we have two options here. So if Yunsi's lunch is equal to Cha's lunch, well, then we're going to print we ordered the same item. Okay. And if not, we'll use our else keyword to print can I try yours? Okay. Go ahead and run this here. All right, can I try yours? That works because pasta and soup, they are not the same, they are not equal, so it's going to run this part of the conditional statement. Okay. Another thing that we can do is use them in a function. Okay. So I'm using this enumeration up here, lunch choice. Okay, so even though I'm working with it down here, I'm referencing my lunch choice enumeration. So I'm going to make a function called cook lunch, okay? And I need to know what my choice will be. So I'm going to pass in a parameter that is a lunch choice. So that forces my parameters to be one of those three choices. I'm going to return a string here. Okay, and let's go ahead and get started with our function. So if our choice is, and see it's up here, so here's choice. If the choice is dot pasta, then we're going to return a string that string that has an emoji. Let's see, get that out of the way. Pasta. There we go. Else if our choice is a burger, then we'll return a burger emoji. Oops. Else, we're going to return a soup emoji. Takes me a little while to find these. Soup. Okay. Okay. So this works nicely for us. Then I go ahead and call my function. My lunch choice is, I put in a dot, and then I can choose burger, pasta, or soup. You see, I only have a limited number of options. If I try to put in cheese, for example, okay, it will not work because the type that it expected me to pass in was a lunch choice type. So I need to actually choose one of those lunch choices. So I use dot notation and I can choose soup. I'll run that and it returns the soup emoji as I had set it up to. Okay. This is an okay option. However, if for some reason I am wanting to, let me reword this. So as we mentioned in our notes, conditional statements are not ideal for enumerations because you want one outcome to be paired with every single case. So while this is okay, it is not our best option. I'm going to just comment that out so I can work kind of cleanly. But I'm still working off of our lunch choice. My lunch choice is still a burger, but now I can use a switch. Switch is its own keyword, as we can see when it turns pink. I'm going to switch choice so that if the case is pasta, then I use a colon, and I put what I want to return right after it. So I'm going to copy this guy. Okay. And if my case on a new line, case is dot burger, colon, then I'm going to return this burger emoji. And for the case of soup, I'll return the soup emoji. So as you can see, there we go. This allows us to set up almost a conditional statement, right? But it doesn't make us go through the conditions. It actually pairs a specific case with a specific outcome. That is an ideal situation for enumerations. We can do one other thing, which is use kind of a default setting for our switches. Our switches must be exhaustive. So let's do an enumeration called quality. Okay. And in that, I'm going to have a handful of cases. So the quality could be bad, poor, acceptable, good, or even great. Okay. Then let's go ahead and initialize this. So my quality, let's start off with good, somewhere right in the middle there. I can create my switch now, quality. Okay. And in the case of bad, we're going to print that won't do. In the case of poor, we're going to print not good enough. But for everything else, we're going to print that's okay. Go ahead and run that. All right, and we have that's okay. And of course, we can go ahead and put this inside of a function now. This switch works better inside of a function than a conditional statement does for enumerations specifically. One other note is that we can group two together. So let's just take out this whole one. So in the case of bad, comma, and dot poor, we're going to write that won't do. Let's see. And a colon, of course. Okay. It's still going to return the same value. That's okay. But if I were to change this to dot bad, then it's going to update. To that won't do. So this is kind of a clever way to group different cases together, or you can use a default case, or you can make a switch for every single case. None is right or wrong. It just depends on what you are trying to accomplish.